Hello everyone and welcome again with another video related to motion in one dimension on the x-axis using the kinematics equations to help us solving the problem. In this example I have an airplane starting at rest uh, at one end of a runway undergoes a uniform acceleration. Excellent. Now, of 4.8 meter per second squared, that's one of the main conditions to use the kinematics equations for 15 seconds before the takeoff. Now, what is its speed at the takeoff? How long must the runway be for the plane to be able to take off? All right, so I have the initial velocity here, 0 meter per second, and the final velocity, not sure how much, I need to find out. Now the acceleration during the runway was 4.8 meter per second, and the time took the pilot to take off was 15 seconds. All right, let's begin with the first one. What is the final speed of this airplane at the takeoff? Now, once again, if we remember the kinematics equations of, or if you have it in with you or from my previous videos, I have the initial velocity, I have the acceleration, I know how much is the time, I'm missing the final velocity. By looking to the four kinematics equations, this equation will be the best to help us solving this problem, and it will be 0 plus 4.8. Oops, sorry, let's fix this one. All right, it's 4.8 times the 15 seconds. So if we do the math, that will give me 72 meter per second when the airplane is taking off. So I know it is 72 meter per second. Okay, that's the final velocity when the airplane is taking off. Now, how long must the runway be for the airplane to take off? So I need to find out how much is the distance this airplane will be traveled or already traveled to take off safely without any accident. Okay, like the previous example or the previous video, you could solve this part of the question in two different ways or use two different equations of the kinematics equations. So I will use first that as a distance, x equal v naught times t, half of the acceleration t squared. Okay, now I know the initial velocity is 0 times whatever, that will be 0 plus half 4.8, and I know the time was 15 seconds, and I'll do the square. Now once again, let's do the math. That will give me 540 meter. This runway must be to make sure this airplane will be taking off safely. Now, someone else might use a different kinematics equation, and looking at how much information or variables I have, I can now easily pick a different equation to find the distance, which is using the final velocity square equal the initial velocity square plus 2a times the x, ignoring the fact I do have the time. I ignore that now. I don't know how much time it's required, but I have other variables already. I have them. Now I know it is 72 squared. I'm sorry, keep doing this. Let's fix it. 72 squared equal here 0 plus 2 multiplied by 4.8, the acceleration, and let's find how much is the distance. If you just do the math and rearrange the formula, so you can do it this way to make it clear to everyone. 72 squared over that's 9.6. Okay, that will give me again, it's gonna give me 540 meter, the length of the runway. So see, I have the same answer by using two different methods. Here is the first one, here's the second one. The same gave me the same answer, which is okay. As we mentioned before, you could pick a different, the more known variable you have, the easy for you to pick different kinematics equation to help you solve the problem. It's just what you need is to make sure that you are picking maybe the easy one to help you answer the question maybe faster without complexity in the mathematical process. Otherwise, everything should be nice and easy. Okay, I hope you find this video useful, and I hopefully will see you again with another example. Thank you.